Welcome back, guys. In this lesson, let's work on some functions. I know a lot of you guys hate functions. I'm not a super fan myself, but if you know what you're doing, all these function questions are really the same kind of problem on the SAT. So try to get a lot of practice on it. Most of you guys know what a function question is. You know, it's a function. It's not a name that I made up, as may be the case in some of my other lessons. But functions, hopefully you've seen these. Maybe in as early as pre-algebra, but definitely in your Algebra 1 classes, and they continue on into many of your higher level math classes. Function questions are things like f of x equals some expression. They could have graph incorporated into those function questions. Sometimes instead of f of x, they'll use another symbol that seems to make the problem more difficult or unfamiliar to many of the students. So I'm going to try to help you understand that all of these different looking questions are really the same kind of question. So see if you can follow along with me in the first couple tests that I'll do with you. I've chosen several of the function questions throughout your blue official College Board study guide. Okay, so follow along with me in that book. I also have the problem for you up on the board, so you can follow along here as well if you don't have your book with you. There are tons of function questions throughout this book. The topic of functions is a pretty significant topic on the SAT, and so I won't be able to do too many for you, but I've chosen, let's see, 6, maybe about 11 questions or so that we'll go through in the next couple minutes. So let's jump to test number 1. In test 1, the first one I'd like for us to do together is section 3, number 18. So let's go there. Section 3, number 18. Okay, so I'll keep the problem big for now and then show you the answer choices in a little bit. They give you a chart, right? Some numbers. X values, f of x values. X is just the x. F of x is always the y. Whenever you see f of x on the SAT, you can always just cross it off and say y, right? If they tell you that f of x is equal to 7, you can just say y is equal to 7. If they tell you that f of x times 3 is equal to x plus 4, you can just say 3y is equal to x plus 4 and so forth. Okay, whenever you see f of x, you can just assume that it says y and you'll have no problems there. Okay, so these are my x values and these are my y values, which means that when x is a -1, in this particular function, your y is 1 over 8. When x is a 0, your y is a half, and when x is a 1, your y is a 2. The table above shows some values for the function f. Okay, so this right here is junk to me. It doesn't tell me anything I need. It just tells me that I have a table. If f of x, so what is f of x? F of x is just y, so I'm just going to write y is equal to k, I don't know what k is, I don't know what a is, to the x power. Okay, I don't know that either. So I just basically rewrote it. I was going to try to see if I can plug anything in, but they didn't give me anything yet, right? So that's what I'm going to write for now. If this is true for some constants k and a, so they tell us that k and a are both constants, as opposed to variables. Variables are letters like x, where it can take on many different values, right? A constant is a number like 2 or 5. 5 doesn't change, it's always a 5, right? So those are constants. What is the value of a? So we're looking for a in the end. A equals something. Well, let's look at what they gave us so far. This is what they gave us. And so how do we find a? In order to find a, right, which is right there, what do I need? I need the values of x, y, and k, right? I need 3 different values. Do they give us any of those values? Do they give us x? Do they give us y? Do they give us k? They don't give us k, but they do give us actually several different values for x and y, right? Where? Right here in this table. They give you several values that you can use for x and y. You can use the first pair, right? X can be a -1 and y can be a 1 over 8. X can be a 0, y can be 1 over 2, and so forth, right? I can use any of these guys, but which one do you use first? Always use the one with the 0 first, because it's the easiest to work out, right? And that's the only one that will actually work in this problem, if you use this guy or this guy, right, you'll end up not being able to solve the problem completely, okay? But if you do use this guy here, let's plug it in and see what happens. My x is going to be a 0, my y is going to be a half, so y is going to be a half, and that equals some k, I don't know what that is still, a, I don't know that either, but my x in this pair right here will be a 0. Now, what is anything to the 0 power? Anything to the 0 power is always a 1, right? 2 to the 0 power is 1, a million to the 0 power is 1, right? So a to the 0 power is also a 1, which means 1 half is equal to k times 1. A to the 0 is just a 1, which means k then is just equal to a half. See, that's what we were able to figure out by using this pair right here, okay? So we know now that k is a half, right? So let me just replace the k here with a half. Okay? Okay, we found that k is half. Remember, k is a constant, which means k never changes. K is always going to be a half throughout the rest of my problem today. So now let's go back and ask us the same exact question we asked ourselves before. In order to find a, since that's what they want us to do, to find a, what do we need? We need an x, that's unknown, right? We need a y, that's also unknown. So do they give us a value of x and y like before? Yes, they do. They give us several different values, right? We don't want to use the same exact value we used before, so don't use this pair. But you have this pair to work with, you have this pair to work with. Either pair will give you the correct answer, the same answer. So it doesn't matter which one you use, but I have a preference. I don't know if you do. I don't like to work with fractions nor negative numbers when I have much easier options to work with. So I'm going to go ahead and use this one. If you want to prove a point and make sure that this also gives you the same answer, you can try that out. But you can trust me on this one. 1, 2 will also work. So I'm just going to use that. So my value of y will be a 2. So y will be a 2, and that equals 1 half times a, I don't know what that is, to the x power. What is x in this pair? X is the 1 in this case, so it's the 1, right? So a to the first is just an a, right? There's no difference there. So that tells me that 2 equals half times a. How do I just find a? Multiply both sides by what? By 2. Right? So half times 2 is just a 1. So I get a, 1a, is equal to a 4. So 4 will be the correct answer for number 18. Let's see if we have that choice. D, therefore, is the correct answer to number 18. Let's jump to section 7. Section 7, number 18. Let's try that one. This one here is the last question of the section, so it definitely won't be an easy one. But if you know what you're doing, it's actually not that bad. So they give us a graph. It's a quadratic graph. It's a parabola, right? A quadratic graph means your highest power, right? Your degree of the polynomial is a 2. So x squared plus 2x minus 6 equals 0, or something like that would be a quadratic equation or a function that looks like a parabola. So in this case, we have a graph that shows the function g. So they call this graph a g. It's a quadratic function where g of x is equal to this guy here for some constant k. Now I'm not going to need the rest of this graph up top, so I'm going to make this a little bit easier for you to read. Hopefully that helps a little bit. We have some constant k, okay? Here's k, that's supposed to be some constant. If this is true, right? G of something, we stick something in there, and that gives me a 0. We'll discuss what that means in a little bit. And a is a positive number. What is the value of a? What is the value of a? So we are looking for a in this problem. And where is a? I look, I kind of read through the problem, what they just gave me. I try to look for an a somewhere. The only place, this is a condition, but the only place they really show me my a is right here. So I know that, of course, this is going to be important to me. I'm trying to find that a. So let's think about this. When can a a function, right, g of some number. When can a function equal 0? Well, what did I say f of x meant in the previous problem? F of x, g of x, t of x, they all mean y, right? So this really says y is equal to 0, okay? And so according to the graph and the given function right here, this function represents this graph, so you can use either one to figure this out. When is y 0? Well, y is 0 when you don't go up any, you don't go down any, okay? You can move in the x direction, I don't care what x is, as long as y is 0, which means since it doesn't go up, it doesn't go down, it has to lie on this x-axis. Where is y 0? At this point here and at this point here, right? And it looks like this is negative 1, 2, 3, comma 0. Your y value is 0. Here it's 1, 2, 3, positive 3, comma 0. So in both cases, your y would be 0. And that's made evident in your function too. Again, you don't need to use this if you can get that information from this one, but here it does say that how would you get a 0? Well, if you put in a negative 3 for x, negative 3, you would get a 0 for the whole thing, right? Negative 3 plus 3 is 0. 0 times anything will give you a 0. Okay, or you can put in a 3 right here and still get a 0. But in any case, I know that if my x value is either a negative 3 or a 3, that would give me a value of 0 for y. So try to make sense of that first. That's the first idea you need to understand. Okay? Once you have that understanding, I'm going to take you back to this part right here. Into the function g, what x value will I need to plug in here to get a 0? We just determined that. We just said that my x value here must be either a negative 3 or a 3. Either one will work, right? If I can put in a negative 3 or a 3, I can get a 0 for the y. So what does that mean? Well, that simply means in this spot right here, right? If you look at this equation, in this spot right here, g of negative 3 is 0. G of positive 3 is also 0. So whatever goes in that spot right here, that can either be a negative 3 or 3. What is in that spot right now? A minus 1.2. And what can be in that spot? A negative 3 or a 3. So whatever is here can either be a 3 or a negative 3. Whatever is in there right now is a minus 1.2, and that can be either a 3 or it can be a negative 3. Okay? So this is all you need. If you solve for this guy, you get a is equal to 4.2, which is the correct answer. This one gives you a negative answer, which is not the correct answer because of this condition here. They want a to be a positive number. Okay, so the correct answer to number 18 is 4.2. Let's jump to section 8. Section 8, number 3. For positive integers, a, b, and c. So again, they call this positive, right? They're not negative, they're not 0. They're positive, and they are integers. Both very important words to notice. Let this thing, and in math that symbol doesn't really exist, but they make it up, which is why they define it here for you. So they're saying that if you have something that looks like this, this means this. Okay? So what is the value of 5, 2, 6 with a box around it? Well, if you compare the given information to what they're asking for, basically they're saying your A should be a 5, your B should be a 2, and your C should be a 6. That's all, right? So this is the same exact thing as the function question because I can actually just rewrite this and say f of, I don't know if you've seen things written this way, but f of A, comma B, comma C, and they just want you to put 5, 2, and 6 in there. So you're just basically replacing the variables with the numbers given. But no need to confuse you there, so let me just erase that in case you haven't seen that form before. And so all you're doing is, okay, whenever you see A, you're saying, oh, that should be a 5. Whenever you see a B, that should be a 2, minus A, once again, is 5, C is a 6, plus, so that's a multiplication right there, plus another C, which is a 6. So by asking you for the value of this, they're just asking you to evaluate this guy, right? Which should be pretty simple. 5 squared is 25, minus, that's a 30, plus a 6. This gives you a negative 5, plus 6 gives you a positive 1. So A is the correct answer for number 3. We're going to move on to test number 2. In test 2, we're going to do 3 problems. So see if you can try these 3 problems out if you have access to the book. The 3 questions we'll be doing in test 2 are the following. We're going to do section 2, number 15. We're going to do section 5, number 14. And we're also going to do section 8, number 3. So if you have a moment, see if you can do that on your own for a few minutes and join me in the next video.